Let's see. Hello. My goodness.
Do you need to do a quick sound check for your computer, or are we all set there?
Let's start with this, and then we just move really quick to the sounding part. I know that we are, oh my goodness. So, okay, in the sake of try to go to the practical part, I'm gonna just read through the abstract and then go straight to the thing, you know? So you have like a whole idea of the thing. So procedural music generation in video games is rarely used in development despite its potential support for interactive narratives and falls beyond broadly used procedural methods like graphic management. Currently, developers rely on pre-produced audio sequences focusing on sound quality while balancing storage and variety. Techniques like layering and resequencing are standard through sound design platforms like FMOD and Wwise, allowing adaptation and interactivity in gameplay. However, this can lead to repetitive audio, which becomes particularly noticeable in extended gaming sessions, diminishing the impact of musical storytelling. This study introduces the Progressive Adaptive Music Generator, PAMG, an algorithmic system that generates continuous music streams based on gameplay variables, seamlessly transitioning between moods, styles, and tension levels. It includes motivation, theoretical framework in the field of generative music, overview of the system structure, and a preliminary implementation test involving a trial game that compares conventional implementation with PAMG. In the discussion section, I address test results and issues and future work. The study reveals a preference for PAMG music over traditional methods in certain aspects, although results are not conclusive. Okay, so basically this machine does is making music in real time and uses some parameters that you're going to see here that come from the video game. And so the video game can control whatever is happening. You can assign that to any kind of variable that you have in your video game. For example, if there is a guy, like a really bad guy that is just chasing you, you can modify the tension according to the proximity. Yeah, so it gets like more tense the closer it gets to you. Yeah. Okay, let me show you. I'm gonna switch over here. So I'm gonna, oh my goodness, I don't want to give you my back, but hello, hello, ooh. All right. So this over here is the, let's say the flow chart of what is happening. The first section is how it generates the pulses. The pulses are like the basic ingredient of everything like here. You will see the pulses going from here, from left to right. We're going to try to see how it works here. So we have an agent network that is going to produce all the musical events. We have a melody agent, a harmony agent, and a percussion agent, and an orchestration agent. The three main agents are these. This is the melody, the blue one, harmony, and percussion. Each one of them has a set of parameters here you can modify. The idea of how this is supposed to be progressive is because every one of these parameters somehow is getting something more complex or tense when I go up. Yeah, that is, I mean, whenever you read the paper, you're going to see that I may have been even overshooting the references for that, because complexity and tension are concepts that are really, really deep in music to study. Nevertheless, this is like one of the implementations that you may see, and is, of course, framing to the Western tonal music to make things complex cognitively somehow within this kind of music. Maybe the style, anyway. Then what you do is that there are presets that are assigned to these corners in the lower part. You see it here. So let me show you a couple of things that happen here. I'm gonna do a reset. So it goes there. And then these XY pads are having each corner has one particular style. At this point in the lower left corner in all of them, there is a style. Then if I move to the other corners, it's going to interpolate between the parameters. If you see all the parameters are moving, yeah, depending, and like fitting until the point in which they resemble this one here is this one, you see? This is the melody agent. This allows for a transition that goes from one style to the other. Okay, let's see. Well, the orchestration agent is around here. Well, you cannot see it like quite well as like an agent in the user interface right now, but what it does is assigns the instruments to these four families of instruments. Well, the piano is by itself. We have strings, we have piano, we have woods, and we have brass. And well, let's continue to see what can we do with this. So the melody agent, this in some ways the director of the timing and is the creator of the rhythmic patterns. So there is something that it produces that is the list. I call it like the move list because it starts like the most simple version of a rhythmic pattern will be just, you know, going with the beat. It's what you do with, I mean, if you try to make a kid follow like the most simple, like repeat what I'm gonna do, it's gonna try to follow exactly the beat. If you go a little bit further, then you introduce some kind of syncopation. So what I did is to move them either forward or backwards to increment, like slowly, the complexity of the rhythm. Yeah. So it produces a list that is already with some kind of syncopation. Then that list is going to be affecting what the other agents are producing in terms of the onsets. They, however, can decide to disagree with that and go a little bit to support the meter, the accents that are produced in the music. Okay, so let's, let me see, well, okay. So the first thing that it generates is a list that is an indexed list with two different properties besides like the actual index. That is the duration and the staccato legato property. So it can be staccato or legato. Then it sends the duration directly to the, like basically the music production. Velocity, I want to say a couple of things about velocity, but then, well, let's continue with this. Then there is a section that produces the pitches. The pitches are produced basically with two types of algorithms. Two of them are basically the random walk, that is like a drunk object in Max if you have worked with that. The drunk object, I had to recreate it because it doesn't produce the same result with a seeding, and I need the seeding to produce like something that you can recall. That is part of how we recognize something as music. That is not just, you know, well, of course there is like an stylistic way to do music that doesn't repeat at all the time, and it's possible to do that here also with the seeding that is 0. So that is also possible. Like it's kind of, okay, you know, improvise on things that are here. Then it works with a harmony. So the harmony, let's go to the harmony. The harmony agent has two functions. One is to produce the harmony, like the grammar for the harmony that is going to be employed. And the other is to produce chords. So it has like a sounding property, produces chords, and it has two ways to do it, like a chord itself or with an arpeggio. So it generates at some point an arpeggio to balance whatever you're hearing. It uses, at this point, it's using a chord dictionary, and those chords are hierarchized in a way to add tension to each one of them by adding one by one each one of the pitches. Let me see if I can show you a little bit of that. Okay. I'm going to take this out. So with this parameter, I can add, if you notice here, more onsets. At this point, it's doing an arpeggio. And I'm going to make it more tense. I don't know if you can hear it, but effectively it's getting more tense. And if I go here, you see here 12? That means that we are effectively dodecaphonic. So basically non-tonal. So at this point it's quite tense. There are other ways to make it more tense. Let's say I go like around here. And this is a complexity for the progression. So in this one, what is going on is that the progression is starting to have more sections with different kinds of grade degrees over the original tone, the tonic, and also has the possibility to modulate. Like a bit about music, maybe you understand what I'm saying. So I can go even, yeah. Let's do something like the most tense that it can be, just with the complexity of the. See some secondary dominance and some modal exchanges and stuff like that all over the place. If I pull all of them up, of course, it's going to be far more complex. There are other parameters that we know in music. There are, for example, range. You see here what is producing. The range is extending the range of what is produced. You see also the register can be up. I can add or rest instruments with this one, just one instrument. So just woods at this point. And I want, let's say, one more staccato. Let's see, I want that in maybe strings. Go back to something a little bit more simple. And then, for the percussion, okay, so something that happens, about the complexity of the rhythm. As I was telling you, this guy here is what produces the move list, which is like the main pattern for the rhythm. They can decide to adhere to that or not. At this point, is this one. So if I put this higher, you will notice that there is some syncopation here. It's trying to adhere to these points in the melody. Oh, I forgot to say, there is a contour parameter that makes this kind of line. And there is another kind of shape that is like long-term for like going up or down throughout several measures or loops that I call here. Okay, let's go a little bit further with the percussion. Let's see, okay, the percussion. Point is following the syncopation. At this point, when I put it down, it's not syncopated, so it's kind of like a marching band. Here is for the kick and the snare. These are the two of them. And check this out when I put it down. Trying to follow the mood list, and this one is trying to follow just the basic beat. I can do the same with the toms. More toms, of course, the more onsets. It's also part of like making more dense and possibly more complex what is happening. Okay, well, the orchestration, as I was telling you, is in charge of moving a little bit the voices throughout the instruments. And is in communication with other properties like the arpeggiator, because it's trying to follow some idiomatic features that some instruments cannot do with the arpeggio. The presets work, as I was telling you, as a set of them that are assigned to the corners in each one of them. Then there is also, so the main thing on how to generate things that are a pattern that can be recognized as music is the seeding in all this. The seed produces a sequence that is exactly the same as before. And I can call several seeds if I need to increment the amount of material that you are hearing. Yeah. Also, I can use a seed for a sequence of seeds, if that makes sense somehow. So that also can be recalled, and then you have several sequences that can come back if you need to. Okay, I think that is that for that. I wanted to mention something about the test. So I did a test. I checked with some students how to compare this kind of music that is generative with music that is normally like the conventional way to create music for video games, that is basically a segment of music that is put there and is triggered. Sometimes it's layered, sometimes it's resequenced. Yeah. So, well, there is the comment that people say, like, you know what, I've heard this music so many times that I have to mute it if I play video games a lot. So he was like, well, you know, that is, and I found the studies. There are some studies that talk about that. And it's curious because they say, well, there are two ways to listen. One is the direct way to listen. It's like, okay, you close your eyes and you listen to whatever is the music. And then how many times you have to listen to be saturated? If you do that in a focus, it's like 8 times. 1, at a time. If you, like music that you love, you have to listen to that 8 times, one after the other, and you say, you know, I'm done. Yeah? But if you're playing something or it's in the background for a video game or for a movie, you can listen to that like almost like 32 times before getting saturated. So that's why this kind of thing that it's been around for a while is not taking over video games that easy. You may say like, okay, I mean, why is not something interactive or reactive to a video game more implemented like in general? I think it's because of that. But anyway, I decided to do the test to see if people can say, okay, this is better or not, or they don't distinguish, or, you know, whatever. So what ended up happening is like this. Well, first of all, with the, you know, the ANOVA test got no significance in the real thing. Possibly because it's also too low. The people that play the game are not too many. Maybe if I do a more extensive test, it will get more results. Nevertheless, in all of them, PAMG was better than CBI, clip-based implementation. And these are the results. They had to score the music of the two implementations of music either with is better, or is slightly better, or is clearly better. Just to the or no, I don't find any difference. So basically 3 different categories of that. The score is from 0, 1, and 2. So for the first graph, it's from 0, 1, and 2. That is the average of all of them. And it was better still for PAMG. And now, by group, you can see that there is something happening here. So that is another problem with the test. I didn't employ a test for priming. So what happens is like this. Whenever you have to play here, you're going to see that, okay, I need to, like, I put my brain to try to play the freaking game. You know, I have to, you know, solve the dynamics, the mechanics of the games and all that stuff. So I'm not paying attention to the freaking music. Then when I get it, I can, So in general, most of the people are grading better the second music because they already have figured out the mechanics of the game. Yeah? Kind of a problem. But it's more or less proven by this. Okay, I think we are ready to play. Who wants to play? Well, give me a second. I'm going to check if the game is working. I'm going to have to do something here first. So the game has already the two kinds of music working. This one is the music that is like in the traditional sense. And if I move it like this is the music generated by the machine. At this point is real-time generation. The other one was, so if I go back, you're gonna hear the isn't it? Let me check if I can. I'm gonna quit the game for a second. It's ready to play. Come here. Let me put a little bit. Anyway, let's try. So you can see the instructions here. You're going to play with the mouse. To be able to play. It's a first-person shooter, so if you have so you can start the game. This guy, you just shoot. the cube. Right. Yes, there. With the, yeah, there. So there are some portals. You're gonna find some portals, and the portals are your friends. They replenish your energy. The bad guys don't die, but when you hit them, they are slower. They are faster than you if you don't hit them. He's losing health all the time. So he gets like, do something, try to find the freaking with the water. You can swim, but if you go too deep, it's gonna lose energy faster. Let's do another try. You wanna play again? Whenever you get to the portal, you can see through the portal where you are arriving. So check if there's no like a bad guy just lurking. Higher when the bad guys are closer. Go with that arrow. Good job. No. Run, Forrest. There, go. Continue. Yes, over there. Got it. One, very good, awesome. All right. Hello, hello. All right. Let me put this thing away. Okay. So that was what I was telling you about the cross thing. That was a little bit better if you had the game in the second group. And then, yeah, of course, this is open for development. If you wanna work with me, just hit me up. I am ready to do more things with this. The next step will be, of course, like a VST. A VST will be super easy to do to have something generative that can be tied to MIDI and automation in a DAW. Super easy. And then making a plugin for Wwise or for any of the engines, which will be really interesting. And I need people that know how to resynthesize samples and also analyze grammar from composers or something like that. Anyway, thank you so much. I'm in touch whenever there are many things to say. This is a far bigger work than it looks like. But I'm ready for anything. Thank you so much. Questions?
Names and illusions, so we can take as many questions as we'd like.
So I know I say this every time I ask a question, but again, amazing work. This goes back to something that I think all of us gamers have wanted forever. I remember going to an early QuakeCon after the Quake 2 release, talking to John Carmack, and they were saying that they wanted to do things like this in that time, in the mid to late 90s. And that was the era of EAX, 3D, and just stereo speakers trying to find some sound thing there. And they came up with some solutions, but they could not crack this. They could not come up with generative music where the tension would build as the danger went up, and things like that. And it was all the problems that you were talking about, and one more that I think hinted a little bit that we saw at the very end of the game, CPU power, right? The ability of the end user to be able to do all these great things that the game does, and then add this on top, right? Where they're really generating these things, whether parts of them come pre-scored or fully generated. So what do you see as a roadmap? Do you find that further optimization of this approach can get it to be embeddable, not just in AAA titles for people who have $10,000 machines, but also for the rank and file that might just play mid-range games or indie games, be able to have access to this running in those kinds of scenarios?
Yeah, well, as far as I've been working, this machine that you're seeing here is 2018. It has a powerful GPU, GTX.
Right?
A GTX.
Compared to those 1998 machines, right?
This is a GTX 1070. This is, I don't know, orders of generations. This thing is not the best machine at all. Yeah.
So is the audio running on the GPU?
The audio is running on the CPU.
That's what I mean, though. So even though we've offloaded all these graphics, we're doing all these other AI pieces and stuff like that on the CPU. So can modern machines running modern games have extra CPU for all this channel audio? I know when I'm playing in my DAW and doing live synthesis, I can run myself out of CPU without trying really hard, and I'm not playing a game at the same time. I'm just curious how complex that is.
So the complexity for the CPU is not as much. So there are two things. One that, so for a video game, the efficiency strives in two things. Is storage, which has to do with the bandwidth to transfer the information, yeah? And the other is processing. So for example, it will be more processing if I had to do synthesis in real time. But
sure, but if they're not just sample playback, right?
These are samples.
Right, so that helps.
It helps, exactly. It needs some bandwidth, but it still is less than what you normally get with a video game, because also it has to do the sound design, some other effects, and sometimes some actually real-time effects in the platforms that you are employing for the video game. So this one is actually not that bad. If you will do something like machine learning or something a little bit more convoluted, possibly will take a toll in the CPU or like the processing unit that you're using for the video game. So as far as it's right now, that is like an algorithmic model, I think it's max 7. That doesn't, I've been checking like how is like the processing, if it's like 100% or something like that. It is not. And this is an old machine. It's the 7th generation of
That's great.
Intel.
I'm so happy you're so bullish on it. So yeah, anybody who wants to work on this, get with them. Let's see this. I want to see it in many, many more games. Yeah.
Thank you, man.
So I have a quick question. As you were alluding to, when this started becoming popular again in like 2002 to 2008 or so, people...
Can you speak a little louder? Sorry.
I'm very quiet. Somewhere around 2002 to 2008 or so, the idea of computational soundtrack and scores for video games was getting really popular. They tried doing this. It sounded pretty bad, and because they didn't have your paper yet. But what they seemed to settle on was a bunch of pre-composed segments and crossfading between them, sort of like, you know, weaponized minimalism, so that you can end the piece whenever you feel like, even though it's pre-composed. Do you see any role for integrating the sort of pre-composed crossfade paradigm into your generator?
Yes. So one of the things that is, as I was telling you just a second ago, if you are interested in working with me, I am completely down to it. I want to make a plugin for a middleware that is called Wwise. Anybody knows about Wwise? So Wwise is the middleware engine that sound designers use to implement sound design and music for video games. What it does is that it can resequence and layer things in music and also in sound design to avoid that things sound exactly the same when they are triggered. You know? So that is the way that it makes like, okay, I know that every time that I shoot, it's not going to play exactly the same sample because, oh my goodness, it's exactly the same. No, it has some random range in which it fluctuates, and that is a way to make the thing more bearable. Those things are already implemented, yeah? And a lot of the music has been using this kind of approach to avoid being like so, like, okay, it's completely typical and stuff like that. Nevertheless, you still hear the same samples. It's not that easy to just, you know, let's pitch shift something like an audio sample or a music sample, yeah, in this case. To just pitch shift it is not, it doesn't sound natural. It's not that easy. So what they do is to put layers on top of that. I couldn't show you a little bit more of the CBI because I employ those layerings to try to do exactly the same as I was doing with the other one, but with a conventional approach. I went last year to the GDC, the Game Developer Conference, and I talked with many people about this, like, why the hell is this not taking over video games? It's like common sense. It should be better. Like, I am not like a genius that is going to employ something that no one has. Yes, everybody has thought about it, and some games have it, but they employ like the Spore. Anybody played the Spore? The Spore has some generative system that makes music in real time. Yeah, but there is nothing like general that you can, you know, I'm going to use this engine for this game and for another game or for whatever you want. So what they say is like this. It's better to have some quality, and also the composers know how to use a modular approach to composition, like how to compose music modularly, so they can put like this module will articulate with this other module, and also can overlay with this other module in terms of the harmony and the like whatever they want, and then they can make things more complex just by overlaying things or resequencing things. So they say, like, you know what? We have like the tools already. We have the people that know how to work with this in the way that we have been doing it. We don't need to create something different. And the problem is that if you want to disturb that market with this, it's going to say like, so the composer is going to say, like, well, I already make good music with the system that I'm doing. I'm getting hired by this. why should I employ this kind of other approach? So there is a thing. What I need to do to make them use this is to be able to gather the grammar of the composer to make their music interactive. Like somehow analyze the music that the composer already made to make some music that is part of the grammar or the style that the composer did, but then make it interactive.
Did you think about, and because a lot of the video game music I grew up with, motif is king. And I was wondering if you thought about that at all, because there could be like a thing that's like doo 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 doo, but then in another part where it's like dangerous, you hear in the bass, you're dun 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 dun. It's the same motif again, but somewhere else, and that brings the unity to it. And that's what composers provide that often generative music just misses out.
Completely. So maybe I mentioned a little bit what I'm doing for creating those motives, and like motives either in rhythm or in melodies or whatever you want, is by doing the seeding random number generators. There are other ways, and also there is a way to say, okay, you know what, let's use a melody that is already done and then vary that melody with some of the procedures that I have there that are kind of simple. They are not like super difficult. There are other ways that we can improve the generation of the harmony, that maybe with Markov or something like that. Those things are really easy for computers. It's not that difficult. But yeah, I mean, basically the melodies or the motifs that you can create are handled by like calling that back with a seeding at this point, is what it's doing.
And with that, I think let's thank our speaker one last time.